Good afternoon. Today we'll be simplifying rational expressions. So, first of all, our learning goals are to review factoring, so differences between two squares, sum and product, and slide and divide, and then we will be learning how to simplify rational expressions using these factorization methods that we have learned. So, first of all, subtracting squares. So, how do we factor this? So, let's say I have give you x squared minus b squared. If I tell you that I can factor this into x plus b times x minus b, will you believe me? Well, this is a true statement. If I use my distributive property here, I will get me x squared plus bx minus bx minus b squared. I cross these out, I get x squared minus b squared. So this is a true statement. So this is how you factor using two squares. When you have two perfect squares, you can factor out in using this method. And then you say, well, why would I want to do this? That makes no sense. Well, when you're simplifying rational expressions, what you're wanting to do is to get the same value on your numerator as on your denominator so that you can cross them out and then keep only the value that you have next to that. So you want to cross as much out so as you can to simplify it. But you remember that to cross things out, they have to be the same. These you can cross out to equal 1. You cannot cross out different things. So when you have, let's say, x squared minus b squared in the denominator, and on the numerator you have x plus b, well, then you can factor x squared minus b squared into x plus b times x minus b, and then you can cross out the x plus b on your numerator with the x plus b on your denominator, leaving you with only 1 over x minus b. So if I give you a different example for difference between two squares, x squared minus 4. This 4 I can transform into 2 squared. Remember, difference between two squares, you always need a square. So it has to be a perfect square. That will be factored into x plus 2, x minus 2. That is my factored form for this expression. Let's give a more complicated expression. I already introduced you to the simplification of rational expressions. Let's say I have your 64y to the 6th minus 16x squared divided by y 8y cubed minus 4x. So this I'm going to simplify into, I need two perfect squares to use difference between two squares. So 64y to the 6th I can transform into 8y cubed squared, and then minus 4x squared over, of course, 8y cubed minus 4x. These I can leave in parentheses. And then on this expression here, I can use difference between two squares to factor. So 8y cubed, so that will get me here 8y cubed plus 4x times 8y cubed minus 4x, all this divided by 8y cubed minus 4x. So you see here I have factored my 64y to the 6 minus 16x to get the same value on top and on the bottom, so that I can cross these out. And then my final answer, my simplified answer for this expression, you see I haven't changed anything. The value is still the same. I haven't changed anything. The only thing I have done is simplified. So my final answer, my simplification is 8y cubed plus 4x. There we go. That is my final answer. Okay, so now you saw difference between two squares. Let's see sum and product. So sum and product, so here I've written slum, that's incorrect, sum and product. I'm sorry, I have written a typo here. So sum and product. Let's say I have an expression x squared plus 5x plus 6. Sum and product is I'm looking for a number that adds up to the b value, so 5, and these same numbers have to multiply into the c value, so 6. What number is this? In this case, 3 and 2. 3 plus 2 equals 5. 3 times 2 equals 6. And then I'm going to write x plus 3 times x plus 2, and that is my factored expression. These are exactly the same thing. These are the same. They're equal. They're just in different forms. This is factored. Okay, so that is how you use sum and product. You look for a number that added to a different number, can be any number, equals your b, and these same numbers multiplied equal your c, and that then you add your two numbers to x and multiply. So that is sum and product. So the sum and product factorization method. Now let's see slide and divide. So slide and divide is essentially the same thing as sum and product, but sum and product you can only use when the a value, so this is a, is equal to 1. When a is different than 1, you need to use slide and divide. So let's say I have an expression here, 2x squared plus 10x minus 12. You see here that a is obviously different than 1. So what I'm going to do, I'm going to slide a to c, so multiply them, which will get me x squared plus 10x minus 24. And then you say, well, that's not correct. These are not equal. These are different. Well, you are correct in making that statement. These are not equal, but this is a step I have to take to get my factorization. So you can't just randomly multiply a by c because you feel like it. That's not a true statement. But when you're using slide and divide, you can use this as a step so that you can get your correct factored form. So now I can use sum and product. So what plus what equals 10, and then that same number multiplied equals negative 24. So my answer here will be 12 and negative 2. Negative 2, so that will get me x plus 12, x minus 2. And now I have slided, and now I divide. So I divide these two numbers by the a value that I have multiplied the c before. So that will get me x plus 6, x minus 1. And then I put my a value back because my a value never changes. So this is my factored form for this equation. I have used the slide and divide method to get into my factored form. Just as a side note here, just so that you know in the future example, if you're doing an exercise, if for some reason you come to the answer of, let's say, x plus 7 over 2 times x plus 2 over 2, for example, okay, then you'll say, okay, my final answer will be x plus 7 over 2, x plus 1. Well, this is not exactly correct. When you use the slide and divide method, to get it into the perfect factored form, you have to take this denominator and put it up here in the x. So your actual factored form for this will be 2x plus 7 times x plus 1. That is your correct factored form for that in this example. Okay, so now let's be simplifying some rational expressions. And then you're going to understand why we were looking at all this factorization. Let's say I have here 2x squared plus 10x minus 12. That is the same example I have used here in slide and divide. Exact same example. Divided by x squared minus 36. How am I going to simplify this? Well, if I use slide and divide here, as we did before, I know that my answer is 2 times x plus 6, x minus 1. So this is 2x plus 6, x minus 1. And then if you use subtracting perfect squares, I can get x squared minus 6 squared, which will get me x plus 6, x minus 6. So this is 2x, x plus 6, x minus 6. And then, well, these two are equal. What a coincidence. When we're multiplying, we can cross out these values. So I can simply cross out these two because these will divide out to be 1. So I can just cross them out. So my simplified form here would be 2x minus 1 over x minus 6, and then I can distribute this to get 2x minus 2 over x minus 6. That is my simplest form. So this here, my simplification, these are equal. These are exactly the same. They're exact same number, exact same expression, only simplified. And I simplified by factoring my statements and then finding where I can cross things out to simplify. That is how you simplify rational expressions. Now let's go to an example here so that you understand perfectly. So if I give you here 4x squared plus 22x plus 10 divided by 48 x squared minus 12. I'm going to be using slide and divide to factor this, and I will be using subtracting squares to factor this. Okay, so for my slide and divide, 4 times 10, 8 times 2 will get me 40, which will get me x squared plus 22x plus 40. Remember, this is not exact math. This is just a method. So now I use my sum and product. So this, my answer for this will be 20 and 2. So 20 plus 2 is 22. 20 times 2 is 40. So then x plus 20, x plus 2. And then I divide by 4, which is my a value, which will get me x plus 5. And then 1 over 2, 2 over 4 will get me 1 over 2. I can't simplify that anymore, so I'll be putting my 2 in front of my x, which will get me 2x plus 1. And then I put my 4 back in front. So that is my factored form for 4x squared plus 22x plus 10. This statement here, I can subtract squares. So first of all, I can get rid of this 48 with this 12 by stating that this expression is 12 times 4x squared minus 1. See, I haven't changed anything here. I've just separated the 12. Transform into 2x squared, okay, minus parentheses 1 squared. And then I subtract perfect squares, so that will get me 2x plus 1 times 2x minus 1. That will be my denominator. And then I keep this 12 here. So my expression is 4x plus 5, 2x plus 1, divided by 12, 2x plus 1, 2x minus 1. I can cross out these 2x plus 1s, which is a very important step. And then this 4 and this 12 I can factor out into being 4 times 3. So this 4, coming from this 12, I can cross out with this 4, keeping me just with the 3, which will give me x plus 5 over 2x minus 1. That is my final answer, only multiplied by 3. That comes from my 12. You see, I haven't changed anything. That's very important. I can distribute this into x plus 5 over 6x minus 3. That will be my final answer. So this initial statement here is exactly the same as this one, only simplified. That is how you simplify rational expressions. Thank you very much.